let's say you are trying to figure out what type of way you can stop fungus from ruining your strawberries in the fridge. Well, what we know about the metabolic processes of life is that there are inevitably many very specific enzymes involved in the way that the fungus is going to actually digest your strawberries. And so what you might want to do is figure out what kind of preservative you can make and how is that preservative going to work. And so there are different types of inhibitors that can help preserve your strawberries. And so the first type is called a competitive inhibitor. And so what competitive refers to is the fact that it's going to compete with the substrate itself for an active site on an enzyme. And so if a fungus was going to be digesting glucose, for instance, perhaps an inhibitor would mimic the structure of glucose such that an enzyme that would take in glucose to the cell would be occupied by the inhibitor instead of the actual glucose. And so to draw out what this would actually look like, if we were to have an enzyme like this and an inhibitor like I would stay in the enzyme's active site and the actual substrate would just stay on the outside because it can't really do anything. And as we know about molecules, they're constantly flinging all over the place. But the point is that we have partially occupied some of the active sites on the enzymes such that the substrate cannot actually bind to them. And a consequence of this is that while the maximum rate of reaction isn't going to be affected, so we're going to say Na, it will require us to have more substrate present to get there. And so therefore, it's going to cause the Monod constant to decrease. And Monod constant is defined to be 1 over the substrate composition at which we reach that 1/2 maximum rate. So there's an inverse relationship, which is the reason why it decreases. But intuitively asking ourselves, why is the maximum rate not impacted by this? The fact is, if you were to flood your solution with substrate, you would dilute the inhibitor sufficiently that it's essentially negligible. And at that point, we're not going to see a decrease in your maximum potential rate. Now, moving on to the next type of inhibition, we turn to non-competitive inhibitors. Non-competitive inhibitors are not going to interfere with the active site. They're not going to compete with the substrate, but they are going to maliciously bind to allosteric sites on the enzymes. And so if we were working with some kind of enzyme that had an allosteric site, that would inactivate it. So this is an unbound allosteric site on the enzyme, and its active site would be able to process the substrate. It would be able to get the transition state correct. When a non-competitive inhibitor comes by, what will happen is we'll have something bound here, and hopefully I don't go too far off the page. This is your inhibitor I. It will change the shape of the active site such that your substrate cannot enter it and you can't react. So this is the non-competitive version. And therefore, what that means is that the Km will be unchanged because we can still realize the same half maximum reaction rate at the same substrate concentration. So Na for the change in the Monod constant, but we do see a lowering of the maximum rate because we have in effect decreased the number of active sites that are available to our substrate molecules. So this number is going to go down. And then finally, there is another type of inhibitor that you'll learn in biochemistry courses called an uncompetitive inhibitor. And what uncompetitive inhibitors will do is bind to the enzymes when they're in the enzyme substrate complex. While the enzyme is trying to get the substrate into its transition state to drive a particular reaction pathway forward, the uncompetitive inhibitor will bind to this and stop it, or it'll freeze the process from moving forward. And the impact of this is that it's going to not only lower the Vmax, but also lower the Minot constant K sub m. And so this wraps up the general introduction to the 3 types of inhibitors you're likely to come across in a biochemistry course. And I do encourage you to really think about the mechanisms and the intuition behind all of these processes, and make sure you fully understand this stuff. It is very important, especially if you're interested in medicine or pharmaceuticals or the chemical engineering side of things. I hope this video helps you guys out. Let me know if you have any questions, and thanks for watching.